Morning, my name is Antony Williams. I work at the Center for Computational Toxicology and Exposure at the US EPA. And I'm going to talk to you today about AMOS. AMOS stands for Analytical Methods and Open Spectra. It is a database and web-based application that is using cheminformatics approaches to integrate methods, spectra, chemical structures, and substance detail into one database. One of the challenges we have when we mesh methods, spectra together with chemical substance identifiers is the consistency of those identifiers. Are we using Cas numbers? Are we using chemical names? Chemicals can have many, many chemical names, so we have to go through that curation process. Cas numbers can be complex. We have active Cas numbers, deleted Cas numbers. We have Cas numbers mapped to neutral chemicals versus the salts. There's a lot of complexity. And when we pull together these data from open resources online, we have to deal with a lot of that curation effort. By pulling together the mappings between the substances, the method documents, the experimental spectra, and making sure we have accurate representations of the chemical structures, we're able to build this rich resource that anybody can use. It's not yet publicly available. Anybody can use inside the agency at this point, but we are working across the agency to harvest data from many sources. So, for example, we worked with USDS, USDA, FDA, DEA. We are pulling data from all of these different groups in terms of method documents. And we're also working with various vendors, including, of course, SciEx, to pull together their information in terms of method documents. There are three broad categories of records represented in the database. These include spectra. We have over 210,000 spectra. It grows weekly. Just this week, we are adding PFAS spectra from our own laboratories. We have 4,200 methods. We harvest these from various sources, including peer-reviewed articles, open access and closed access. We're pulling those methods from across government agencies, including all the way into Europe. Most data are open access, but in some cases, we do just have external links to other systems online. The data are continually updated. We are working this on an ongoing basis, very active project. We do a lot of this to support non-targeted analysis efforts going on within the agency. And we focus, of course, on where the interests are within the agency, but also as we talk to people, we can think about emerging chemicals of concern, for example, some of the tire wear particles like 6-PPD, etc. We put our efforts into those chemicals that would be of most interest. One of the challenges, as I mentioned, was the curation of data. So if we are pulling data with different Cas numbers, and you can see here, this is the fluorotelmer alcohol 307-460 Cas number, top right-hand side. This is the Cas number. This is the active Cas number. Many chemicals can have deleted Cas number. You can see that there are systematic names here, subtly different, but they're all out there being representative of this chemical, and all of the individual slight differences in the chemical names. We have to map this together so we can make it all a part of our chemical registration system. I'm going to move to a live demo, and I'm going to go back to the home page, and I'm going to search for atrazine. So atrazine has pulled up a set of results, 244 in total. We have 101 methods. Some of these are rather old methods. You can see that these have actually been, these are scanned in methods. We actually have some of, all of the US EPA methods that are loaded here. And what we are doing, as I commented, is we are pulling the chemicals based on name and Cas number out of these documents and then mapping them into our chemical registration system. We also have USGS methods right here. We have, in some cases, we have the open access journal articles, which we load directly into the system. We have Agilent methods, etc., Thermo Fisher methods. And of course, I will be showing some SciEx methods as we move forward. So on the spectral side, we have spectral links. Those go out to the external website called SpectraBase. We also have our own spectra being loaded into here. We've got the spectral points and the information about how they were assembled, etc., etc. So this was from labs with Seth Newton, John Casey, and you can see how many spectra we have in here, including from sources such as the Human Metabolome database, etc., etc. We also have what we call fact sheets. Fact sheets are things such as worksheets from different states, hazardous substance fact sheets. This is from New Jersey. This is the IRIS assessment of atrazine, etc., etc. So in terms of PFAS, if we go look now at PFAS, this is the chemical. If you want to know anything about the chemical in terms of hazard information, all of the toxicity data we might have on this chemical, this is linked up to our database that we have in running called the CompTox Chemicals Dashboard. And this is where you would harvest information about the chemical in terms of executive summary, links to Wikipedia, etc., etc. So this is the CompTox Chemicals Dashboard. But let's go back to Amos for a moment. So here we see that we have 108 methods in total. We have the ASTM method. Now in this case, this is not open access, but what we do is we extract the chemicals from the method. So you can see the chemicals directly. We link you to the ASTM method. So you can click right on this hyperlink and it takes you to the ASTM page. Now you will have to pay for that method because that is not open access. We also have links out to, for example, CDC. This is their lab procedure. We have ERDC. So this is some of the work going on at the Department of Defense. Open access articles. In all cases, we're extracting the chemicals. So you can do, this is how we're able to do a chemical search to find the methods. We have indexed all of the chemistry below that. We also worked pretty closely with NIST to pull all of their detailed information about certificate of analysis. So this Great Lakes sediment will have PFAS chemicals mentioned in here, as well as PAHs, etc., etc. We also have their reference material detailed. We've been working closely with SciEx in recent weeks to pull the SciEx methods directly, so you can see the residues in food, drinking water, etc., etc. We're very grateful for SciEx to provide this information to us, where we are once again going through the documents, we're extracting the chemical names, in this case these abbreviations, and we are mapping them to our structure database. I'm going to switch mode for a moment because this was a single chemical search, and I'm going to go to methods browsing. So in this case, what we have is the 4,236 methods. This will be updated again tomorrow. It will cross 4,300. I happen to know how many we're loading. What I want to do now is I want to browse through here and filter. So I'm going to filter this down for PFAS as a class, and I want to look at water, and I want to look at the source, SciEx. And here we can see drinking water, salt water, surface water, etc., etc. We have the limits of quantitation and detection. This will be split out shortly. This is a proof of concept, so we get to make adjustments very regularly. Once we push this application publicly, it will be a lot harder for us to adjust the code once we've scanned it, etc. But right now, because it's internal, we add new functionality. Once a month, we push new code out. This is the method details right here in terms of the method identifier, number of chemicals in a specific method, and double click, and it takes you directly into that method document. So I will now reset the filters, and what I'm interested in doing is taking a look at other types of chemicals. So for example, I'm looking for 6-ppd. So now what I've done is I filtered through the entire table, every text string, to find anything we know about 6-ppd. And here's an example of going into the 6-ppd quinone. This is talking about suspect screening of compounds derived from rubber. And here are the chemicals associated with it. Because we have been able to map the methods and the spectra directly to structures, we can now take advantage of a way to do similarity search based on chemical structure. So as an example, if I look for lysergic acid, just to see what we might have, the answer is it brought back no methods. It has no methods here. It has a link to a spectrum, but that's an external link only to SpectraBase. So how would we start developing a method around this? So in this case, what we would do is go to the similarity search. I'm now going to search for lysergic acid directly. So what it does is it finds the chemical lysergic acid in our database. It knows its structure. It then uses a similarity search of all chemicals mapped to methods to try and find other chemicals of interest. And in this case, not surprisingly, lysergic acid being LSD, it has done a search to find the most similar chemicals. This is a derivative metabolite of LSD, lysergide, etc., etc. And it found them in this article about highly sensitive determination of psychoactive pharmaceuticals. It turns out that this one is a closed access article, but you do have access to the title, the authors, the abstract, and one click, and you are out to the website doing a search based on DOI. But we also pulled back many other chemicals here. Here's an Agilent application note. This is a Journal of Food Control, etc., etc. So this is a way to do similarity searching based on chemical structure to find a good starting point for methods. We've also given you a batch search here. At the moment, this is limited to searching based on our DTXS IDs. These are our substance identifiers. And I'm going to go to our Comptox chemicals dashboard that I mentioned previously. I'm going to pull a list of chemicals. So I'm going to look at a list of extremely hazardous substances. I'm going to filter out multi-component structures and chemicals without structures. And I'm going to send this list over to the batch search. So I just want to pull a list of DTXS IDs here. So these are our substance identifiers that are held within that database. Comptox Chemicals Dashboard is accessible to everybody. It's free of charge. You don't need to register. It's very, very highly used by the community at this point. It's been online for a number of years. First version went online in 2016. So now what I'm going to do is I'm going to open the results of that batch search, and what that has done is it has taken the DTXS IDs, it has done the search to see what we have in terms of mappings, and we can see here, based on that chemical, we can see whether or not there are different spectra available. Now in this case, you can see we have NMR, IR. These are links to SpectraBase. We don't actually host at this point NMR and infrared in the database. So what I'm going to do is I'm going to filter out and find the methods directly. So this is standard Excel functionality. I'm going to just look for the methods and the spectra. I'm going to filter out the external link so that I remove SpectraBase. Now what you can see is we have many different links for the chemicals. So these are all the individual identifiers for the methods. This is where they came from. These are actually the hyperlinks to those methods online. Here's a description of what the methods are, etc., etc. So it's really easy to do batch searches. Going back to the methods here, I want you to consider how long it would take for you to try and harvest information for a chemical of interest from methods online. Most people go to Google. This would be your path forward for a starting point for any chemical of interest. So if I want to find anything regarding morphine related chemicals, so dimethylmorph, morpholine, etc., etc., we can filter in this way. We can also start looking at what we have on different tissues. So muscle tissues, veterinary drugs, PFAS, etc., etc. So AMOS, Analytical Methods and Open Spectra, is a growing resource, not yet public, where we are pulling together all of the data using our efforts to curate the information, put it all into one simple system that people can utilize. We are very grateful to SciEx for providing their methods. We continue to expand this resource at this point, and we're looking forward to getting more methods and application notes integrated in the near future. Thank you very much.